Okay, so we're going to switch to a screen share here because there's going to be some Praat wrangling in this video. Yeah, so we just saw that sometimes the properties, the features, the aspects of consonants in particular, or stops in particular, but also other sounds that we need to pay attention to are going to have more to do with the surrounding context than they do with the actual stops themselves, right? And more generally, it's going to be useful to distinguish between acoustic events that happen during consonant constrictions, where a constriction is just any kind of narrowing of the vocal tract that you're going to be doing for any kind of a consonant. This is going to be different for different consonants, right? So sonorant consonants like nasals, liquids, and glides, they have formants like vowels. We saw this when we looked at some of these sounds in Praat. And so those are going to be useful for identifying those sonorant consonants. They're going to have internal formant structure or internal cues. Fricatives are going to be a period of noise that's sustained. It's a long period of noise, and the frequency of that noise will depend on their place of articulation. So one of the big ways that we tell the difference between s and f has to do with the frequency of the noise. Although also, like stops, the transitions to and from adjacent sounds will also be important for fricatives. And then for stops, especially voiceless stops, there's going to be very little going on during the stop closure itself that allows us to identify any of the properties of that stop other than maybe being a stop, right? So for voiceless stops in particular, there's going to be basically silence during the closure, right? Because there's no airflow coming out from your oral cavity, and your glottis isn't vibrating, so that's not making any sound either. During voice stops, you may be able to hear the voicing going on during the stop closure, even though the vocal tract is occluded and is closed and there's no airflow coming out. You may still be able to hear that voicing radiating out through the tissue in the front of the face. That's sometimes referred to as closure voicing or a voice bar, and it is often audible in speech, but very, very quiet, and it's not going to really tell you anything about the place of articulation of the stop. It will tell you about its voicing. Right? There's also, as we just saw, acoustic events that happen surrounding consonant constrictions. And this is what we were talking about in that last video with the parts of the articulatory system moving around in time. And articulators are going to be gradually moving towards the place of articulation of adjacent sounds. That's going to change the vocal tract configuration, the shape of the vocal tract. And because, as we saw last week, any change in vocal tract shape is going to cause a change in resonant frequencies, that means that moving your articulators is going to change the formants of a sound if there are formants present. So in particular, if you have a vowel preceding or following, say, a stop, and you're moving your articulators to get them in place to create the stop constriction, but there's still acoustic energy and formants from those vowels going on, then you're going to be able to hear or see in Praat the formants moving around depending on the place of articulation. Now for stops, there's also the properties of the burst itself that are different depending on the place of articulation, and that's going to be important, but not quite as important as you might think. So what are the results here? Well, the perception of the place of articulation, just like laryngeal properties for stops, is going to depend mostly on acoustic events in the surrounding context rather than anything that happens during the stop constriction itself. Right? So that burst or that transient is going to be important, but formant transitions are super, super important for hearing the place of articulation of a stop. So here's a question that Fujimura and colleagues start with. When we talk about their importance for hearing stop contrasts or for hearing place of articulation, are the preceding transitions or the following transitions more important? That is, are the acoustic changes from a vowel going into a stop, that is a VC transition, are those more important? Or are the transitions from the stop burst going into a following vowel, or the CV transitions, are those more important? They're going to try to answer this question. How are they going to do that? Well, they're going to use artificial splicing together of sounds to give listeners conflicting information from the two sources. Right? They're going to have, listeners are going to hear the VC transitions into, say, a labial stop, but then they're going to hear CV transitions coming out of, let's say, a coronal stop, and then we're going to ask them what they hear. The more important set of cues, do we care more about the preceding transitions or the following transitions? Those are going to determine what people hear. When a stop occurs between two vowels, there's going to be formant movement both before and after the stop closure. That's because you need to get your articulators into place to create the closure. That involves moving them and changing the shape of the vocal tract. And then when you release the stop, your articulators are going to move towards the configuration for the next vowel, and that's going to change the shape of the vocal tract as well. Those are both going to create formant movements. We refer to these as formant transitions into a stop closure and out of it. Now, normally in like real life speech, the formant motion or the trajectory into the stop and out of it is going to be the same. They're going to be consistent with one another, right? So if you hear a stop sound that starts as a buh, it's generally going to end as a buh as well in speech. But by artificially creating conflicting information, we can force listeners to choose between the two sets of cues. Does this sound more like the thing suggested by the preceding transitions, those VC transitions, or more like the thing suggested by the following transitions, those C to V transitions? And here is how Fujimura and colleagues did this. These pictures are spectrograms. They look a little bit different than the ones we get on our modern computers. This is from 1978, after all, but it's basically the same thing here. And I think what you're seeing, this is one natural stimulus. Maybe it's an aba or something like that. This is a second one, and maybe it's something like an ada. Right? And at the bottom here, we have this low frequency energy. That's probably voicing. So just showing you that voicing is going all the way through. And then there's some formants here. This is probably F1, F1, probably F2, although it's a little bit hard to see here. And then F3 and F4. And what you can see is that if you look real closely, especially in the original handout file, this might not come through clearly on the video, you can see the formants moving down here and then rising back up. Moving down here, rising back up. The second formant looks like it's going up here and then falling back down. And these transitions, these movements of formants are going to largely determine whether we hear a labial stop or a coronal stop or a velar stop, depending on what you're actually examining. So here's what they did. Here's what's going on. These dark patches are the vowels. This is ah, and then closure, this sort of near silent portion, and then release, right, to the next vowel. The second vowel is here. Same thing, first vowel, closure, second vowel. And here's what they did. They took the preceding vowel and all of the formant transitions into the consonant, and they chopped it out of this natural sound file. And then they took the formant transitions into the following vowel, but not the burst, and they chopped it out of this file. And what they did was take the closure from this one, labeled A here, the release from this one, labeled B here, and they just put them together to make this artificial stimulus that starts out being an aba sequence, but ends up being an ada sequence. And we're going to ask people, hey, what do you hear? They used recordings of a Japanese speaker saying aba, ada, and aga. They checked to make sure that both Japanese and American listeners could hear the differences between the bud, duh, and gus stops reliably. And then they did this splicing procedure. So the VC transition from one word or utterance, this is the A over here, and the consonant to vowel transition from a second word, and that's the B here, and they put them together. They left out the burst. There's this tiny little burst here. You can barely see it. They left this out of the stimuli because they wanted the two sides to be as symmetrical as possible, in part because it really means comparing formant transitions to formant transitions, right? Not having one of these places of articulation also favored by the burst. But then also, this actually allows symmetrical testing, and they tried this. You can play these stimuli forwards, and you can play them backwards as well, and they're going to sound also like aba or ada sequences because they're completely symmetrical. It's vowel, closure, vowel with no burst intervening. If the burst was there and you played this backwards, it would sound extremely weird because it would have a burst right at the end of the vowel before the closure. Your ears can't process that. So by leaving that burst out, they created symmetrical stimuli. So the test here is what do listeners perceive? And before I tell you the answer, I'm going to demo this. Let's just do this in Praat. With the miracle of modern computing, we can just replicate this experiment in a miniature, informal way in a few minutes. So let me make sure this is centered in the screen okay. Here's the Praat objects window. Can we see this? All right. Yeah, cool. We're going to record a sound. This is under New, Record Mono Sound. What am I going to call this? I'll call it Fuj Stim for Fujimura stimuli. And here's how you do this in Praat. It opens up this sound recorder window. You press record, and then you can stop it, but don't close the window until you've saved the file or you'll lose it. So here's my attempt to do this. Abba, ada, aga, abba, ada, aga. Okay. Now, I have not actually saved this file yet. I need to press Save to List. Now it's there. And even when it's in my object window here, this still hasn't been saved as a file on my computer yet. In order to do that, I'm going to have to use the Save menu and put this in a folder somewhere on my computer. But for now, I'm just going to manipulate it. Let's see what this looks like first. Did this come out okay? Yeah, that looks pretty decent. That first one looks a little bit funny and louder than the rest, so I'm going to focus on these three. Again, let me make sure I'm in the viewer window here. We see this okay? Yeah, that's fine. Okay, good. Ada, aga, abba. There we go. So let's select and move in here. And we find, what was this? Ada, aga, abba. Ada, aga, abba. In each of these, you can see two clear peaks. These are the two vowels. I guess I'm producing this with a little bit more stress on the second vowel. It's hard to produce perfectly even vowels for an English speaker. And you can see that it gets much quieter in between the two, although there's still some sound in there. Let's chop each of these out and make a separate file with them. So I'm going to select one of these. I'm going to zero out both of the left and right sides so I don't get clicks at the edge of it. In the menu, you can do this here. Move start of selection and nearest zero crossing. Move end. I'm using the shortcut keys. And now I'm going to go to File and Extract Selected Times. And there's options here for what you want to do with the time annotation. Doesn't really matter. I'll do this one. That should now write just this portion to a new file in my object window. Let's see. Ada. There you go. I'll do the same thing for this one. Aga. And then I'll do the same thing for this one. Abba. Okay, so now we've got our three files. I'm going to give these names so I don't forget what they are. And I'll call this one VDV for Ada. This one will be Aga. VGV. And this one will be VBV. Abba. Oh, sorry, the rename window may have just popped down. No, you should have been able to see that. If that didn't show up fully on the screen, when you press rename, there's a little window that pops up. You write in the name of the file. Again, these are not saved to my machine. They're only saved to the Praat object window for now. Right? So what are we going to want to do here? Let's take, let's take the closure of a duh sound and the release of a guh sound and see if we can combine them. So how are we going to do that? Well, first I'm going to copy this one, and I'm going to give this a name that has the closure of duh and the release of guh. So here's what this looks like. This is the natural sound still, and this is going to be a closure here with duh, and then a release and another vowel here. We're getting bad formant measurements at the moment. I think that's because I was doing crazy things with the formant settings when I did my last video. I'm going to return this to standards. That means all the things that you normally start with in Praat. See how that does. That's certainly a little bit better. I'm going to try this. Even better. Okay. So this is and then there's a little bit of echo in here, but it shouldn't be too bad. Let's compare this to the guh one. And what do we see here between these two sounds? Well, it looks like F1 is falling into both closures. That seems to be true in both these places. F2 seems to be rising into both closures. But F3 here, interestingly, seems to be mostly flat for the duh sound, but falling and then coming back up for the guh sound. So that's going to be the main difference here between perceiving these two places of articulation is going to be that third formant. But in any case, the main point is just that there are different patterns of formant movements for this duh sound than there is for this guh sound. Okay, so here's what we're going to do. We wanted the closure from the duh sound and the release from the guh sound. And you can cut and paste in Praat just like you would in a word processor or something like that. So I'm going to get in here close and make sure I've got the right exact moment I want to chop. And as I get in close here, this is the closure of the duh. And then here's this little tiny burst. That's going to sound like this. That is a coronal burst. I want to cut just before that, and I want to make sure that I cut this exactly at a zero crossing. So I'm going to make sure that I select Move Cursor to nearest zero crossing. Now, I'm going to take everything in the file after this point, and I'm just going to delete it or cut it. And now we've chopped out the entire release of the duh sound. What does this sound like? I can pretty clearly hear a coronal there. It sounds like the end of a word that ends in ud, but with an unreleased stop, which is pretty common for coronal stops in English. So I can pretty clearly hear the coronal stop there, even though we just chopped out its entire burst and release. Now let's go into the guh sound and try to get the release without the burst. So I've just zoomed in by pressing SEL, by picking this interval and pressing SEL. This is going to be part of the guh closure and its release. It'll sound like this. Yeah. And so I'm seeing a little burst right here. It's hard to even really see in this token. It has a pretty weak burst. So I'm going to chop it right here after that burst. Oh yeah, you can hear that very clearly. And so there's no burst in following that. Again, I'm going to zoom out. I'm going to go grab this. I'm going to make sure that both sides are zeroed out again. I'm going to cut this or I can copy it to my sound clipboard. Maybe I'll do that. And then insert it right here where I just chopped the duh sound. You can also do that with the edit menu. So paste after selection. All right, and what do we get here? Well, this looks much like one of our original stimuli. There's two vowels, there's a closure in between. There should be no overt burst in this one anymore. We just have formant transitions in, and as you can see here, slightly mismatched formant transitions out. So we have closure from duh, release from guh. Which one is it going to sound like? A guh or a duh? Here's the answer.
A guh, a guh, a guh, a guh, a guh.
And maybe the audio here isn't great. This is not obviously a perfect, beautiful stimulus. This is something I'm doing very quickly and not very carefully. But I pretty clearly get a sensation more of guh from that than I do of duh. And that's exactly what Fujimura and colleagues found, that this C to V transition, the release and the following formant transitions, overwhelmingly dictate what people hear, much more so than these preceding V to C transitions. Now, another thing you might be hearing here is a sequence of duh and guh. Udguh, udguh. That's because in English, it's very frequent for the first stop in a sequence like that to be unreleased. And that would sound a lot like what we're getting here. Even though I made this artificially, it's not going to be that different from a sequence of two stops in English where the first one's unreleased. If we want to try to do away with some of that, we can also try cutting out some duration from this closure period. And so I'm going to do SEL again, zoom in on this closure. If we just delete some of this, and there's very little in there, as you can hear, this is basically just voicing radiating out through my neck. We chop a little bit of this out and make it shorter. It's going to sound more like one stop and less like two stops. So maybe I'll just take a couple periods in here and chop them out and see what that does. So now I've zeroed everything out again. I'm going to cut. And if you heard two consonants before, maybe you'll only hear one now.
Aga, 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 aga.
So it sounds to me, again, like maybe a funny aga, but more like aga than a da. Right? So this is essentially what Fujimura and colleagues did, a little bit more systematically and with lots and lots of listeners and so on and so forth. But the basic result here is actually not hard to obtain. It really does overwhelmingly seem to be the case that listeners go with the CV transitions, the consonant to vowel release transitions, rather than the VC ones. Yes.